The correlation coefficient R is calculated using this formula right here. We have 1 over 1 less than the sample size times the sum, and that means add up a bunch of stuff. And what we're going to add up are going to be the products of these two expressions. Now what we might notice here is that these expressions represent the formulas for finding the z-scores for x and for y. The little subscript I here is just a placeholder for the number of the term in the list of ordered pairs. For instance, this data set here gives us 6 x values corresponding to 6 y values. So I would run from 1 to 6 for the z-scores for x, and I would run from 1 to 6 for the z-scores for the y's. So if we were to calculate these z-scores, then in our column here for z sub x, the z-scores for the x values, we'd have x1 minus x bar over sx, x2 minus x bar over sx, and on down like this until we got to x6 minus x bar over sx, and then same thing with the y's. y1 minus y bar over sy, y2 minus y bar over sy, on down to y6 minus y bar over sy. And then we could make ourselves a scatter plot of these corresponding z-scores for x and y. So for this ordered pair, x1, y1, we would have this ordered pair for their z-scores, and it might be somewhere around here, we don't know. And then we would go on down and create the scatter plot, whatever it might look like, for these z-scores. And then if we were to find a line of best fit, it might look something like this. Now this line of best fit would have a slope. And our form for our regression line, or our line of best fit, or least squares regression line, looks like this. But for the z-scores, that equation would look like this. The predicted z-score for y equal to a plus b times the z-score for x. And it's this slope right here that actually corresponds to r. That slope for the scatter plot of the z-scores is the correlation coefficient. So we might write this out. The correlation coefficient is the slope of the line of best fit for the scatter plot of the z-scores. Now let's look at an example. Here we have some correlated xy values. And I'm going to construct a regression line by clicking Stat, Regression, Simple Linear, choose the x values for my x variable and the y values for my y variable. And something that I want to do is plot the fitted line and plot the residuals versus the x values. Click Compute, and let's note the R value here. The R value is 0.97917841. Let's also, though, look at the scatter plot. We see that the scatter plot is pretty narrow and does appear to be linear, and the plot of the residuals does appear to be randomly distributed above and below the line y equals 0. So this R value, 0.979, we just stated is the slope of the line of best fit for the scatter plot of the z-scores. Well, let's look at that. Let's go to Stat, Regression, Simple Linear, and now let's make a scatter plot of the z-scores. So here we go. There's zx. Here is zy. We want to plot the fitted line and hit Compute. Now we have this slope for the z-scores, 0.9791781, just like the R value for the XY ordered pairs. And we'll see then that we have this line of best fit for the z-scores. Let's look at another data set. Okay, so we have another set of XY ordered pairs, and their z-scores are already calculated again. Let's look at the regression for the XY ordered pairs, going through the same process. Let's plot the fitted line and the residuals versus the x values. Compute. And this time our correlation coefficient is minus 0.98761747. And let's look at the line. The scatter plot does appear to be linear. And this time it's negative. And again, the scatter plot of the residuals versus the x values does appear to be randomly distributed above and below the line y equals 0. So let's remember our R value here. Our correlation coefficient is minus 0.9876 if we round to 4 decimal places. Now let's do a regression on the z values again. And we'll plot the line. And here we see that the slope for the line of best fit for the z-scores is the same as the correlation coefficient for the ordered pairs x and y. Something else that we want to note is that for both of these plots of the scatter plots for the z values, the line passes through the dot 0, 0. And what does that mean? That means if I put 0 in for x, I'm going to get 0 for y. And in both of these plots, this line of best fit passes through the dot 0, 0. Notice when x is 0, y is also 0. Let's look at our negative slope model. Again, when x is 0, y is also 0. And the reason for that is because a regression line is always going to pass through the means for the x and y values. So let's write that down. The regression line will always pass through the dot x bar, y bar. The ordered pair represented by the means of the x values and the y values. Remember that the z-score is the distance a data value lies away from the mean. So at the mean, that value would be 0. The z-score would be 0. So it makes sense then that the line of best fit for the scatter plots of the z-scores would pass through the dot 0, 0.